It's me again, back in the shack. Let me turn my radio down, listening to the 40 meter Ole Miss Net, which I'm a member of, and I will check into. But I got a little problem. You can look at my previous videos, and behind the antenna tuner and the radio, I had a power supply. It is a Pyramid 13.8. It's a variable power supply. I had it set on 13.8, and it sat back there in the corner. But we had a little lightning storm, and I should have turned things off, but I didn't. And so as a result, my power supply went out. We apparently got a electrical surge, and so I had to go back to the bench over here, and there's a power supply. But let me show you what I had to do in between times, and that was I went down to the local garage and purchased a $20 old battery and a charger and hooked it up so that I would have 13.8 volts DC supplying my radio. I can't be without that ham radio, and I wasn't going to let the power supply stop me from getting on the air. And so, as I said, a lightning surge occurred, and I had to figure out what was wrong with the power supply. And I've already taken the cover off. It is as you can see, a Pyramid model PS-2XKK. Excuse me, model PS-26KK. It's basically a variable power supply with a watt meter, amp meter, and I usually set the voltage to about 13.8 to 14 volts to power my radio. But as I said, I had trouble. So here's some of the things I did. First thing I did was go on the internet and find me a schematic of the power supply, and right off the bat I happened to notice it's a rather I don't know, I won't say complicated schematic, but there are 4 power transistors that you see there, and as I followed the supply, there's the voltage regulator, which is an integrated circuit, and but right here is the AC input, and like I said, my wife is the one who said, "You probably got a lightning strike," and she was right. And so I noticed that the AC input is here, and we have the transformer, of course, and immediately following that is this bridge rectifier. And so that was my suspicion all along. It is a 25 amp voltage rectifier, full wave rectifier, which is kind of interesting. The way it was wired, one of the taps was left not connected because the rectifier itself, being in a metal case, which you'll see here, in a metal case, it is ground. So there were only 3 wires connected, soldered to the posts of the rectifier. So I suspected, after some testing with the volt-ohm meter and continuity, that I had a blown rectifier. I was still kind of felt strange about it, that the rectifier had a contact right here that had nothing soldered to it. But after studying it and testing it, and even looking at the data sheet on it, it is ground, which is the rectifier itself. It's in a metal case. It's a 35, can't remember exactly what it is. It's got a number on here. There it is. Let me turn it around. I don't know if you can see it or not. It is a KBPC 35-01, meaning 35 amps. I went back with a 50 amp rectifier because I felt like that was probably the best thing to do. After studying the schematics of an Astron power supply, they use a 50 amp. Schematics were similar, but they use a 50 amp, and so it is actually a 50 amp rectifier that I went back into the supply with, and I'll show you that. I've changed positions, took the cover off, and as I said earlier, only 3 wires were connected to that bad rectifier, so it didn't take me long to unsolder and resolder the new rectifier, the 50 amp rectifier, in place. Now, I've not mounted it back yet. Again, here is the connection that is left with nothing connected to it. That was kind of strange. Most full wave rectifiers that I've used before have always had 4 connections across it to be full wave. Of course, there are half wave rectifiers, but this is a full wave rectifier, and you can see down there that there is a compound, a heatsink compound, that was placed on the old rectifier before it was bolted in, and I have not yet put the compound on. I have some compound, heatsink compound, that is used for applications like this, or for if you've ever done any work on a CPU in a computer. Most CPUs have some kind of thermo compound that helps bind it to the heatsink. Well, the case itself is the heatsink, and it is also the ground, and that's why I didn't need a wire on the terminal here. These two are the secondary windings, and this particular wire right here is the wire that goes down to the filter. Let me see. On the pyramid supply over in the corner is a set of capacitors and other circuitry that does the filtering. So this particular lead right here goes to that circuit board, and these are the secondary windings from the transformer that you see right here. That is the primary side. This is a secondary side. You got several different voltages there, but I'm interested in the red wires. That is the power output of the transformer from its secondary stage, and it basically is a simple repair. And my gosh, the part cost me $5.04 and $3 for shipping. So for $8, and I could have got the part cheaper, but I trusted the place that I ordered parts from, and I paid a little more. It was $5.04 plus $3 something for shipping. And so for $8, I fixed my power supply that I thought I was going to have to replace for a nice sum of anywhere between $150 to $200 to have the power supply that I actually wanted. I learned a whole lot about power supplies through this event, and what I lack now is spreading the compound on the back side of the rectifier and bolting it down over this post that you see down here. It will set down on that post. Again, there'll be a white compound that I'll spread on that, and I will bolt that sucker down, which will help be a ground as well as the heat sink compound, and help relieve the heat in the power supply. There is a nice fan right here in the power supply. These are not the best power supplies, the Pyramid brand. Some of the parts are inferior. If you're comparing power supplies, actually the best power supply in my research that you can buy is an Astron power supply. You pay a little more, but I always believe that you get what you pay for. So, but I hadn't, when I bought this power supply, it came with a radio. So, rather than spend $150 to $200 on a new Pyramid power supply, I decided it might be possible, after looking at the schematic, that it might be possible to repair this one. And I had a gut feeling about it as I tested the bridge rectifier, that was probably the problem. And after doing some research, it's a typical problem of power surges. I did go back with a 50 amp, and I have tested it, and I get a good variable voltage out. That's pleasing to me. So the thing that I need to do now is bolt the rectifier down after I apply the heatsink compound and put the cover back on. There's several screws, and when I do that, I will locate it back over there in the corner behind the radio and the antenna tuner that I did a video on, and it will sit there and hopefully give me service for many more days, months, and even years if I would just learn to disconnect it or turn it off during an electrical storm. So that basically is a simple repair and a very cheap part to keep this power supply in service. So hope you enjoyed the video. This is Kilo Fox 5 Sierra Kilo Papa. I am a ham radio operator, and this is part of what ham radio is all about. Thanks for watching. Click a like, and leave me some comments. Thank you again. Thanks for watching.